Hi, this presentation will go through some problems in Geometry Chapter 6. For our first example, question says, in triangle ABC, if AD is equal to 32 and BD is equal to 18, then find CD. So let's label what's given, the 18 and the 32. At first it doesn't look like a lot of information, but what we know is that there are three triangles that are similar here. BDC is similar to CDA, and they're both similar to the overall triangle. So I'm going to label one more side. I'll put the X in here, and you can see that the X is the long leg for this triangle and the short leg for this triangle. In similar triangles, sides that are corresponding must be in proportion to each other. So we can set up this proportion which says 32 is to x as x is to 18. And then by cross multiplication, we get x squared is equal to 576 and x is equal to 24. For our second example, it's pretty similar. Why don't you try to set up a proportion on your own, and in just a few seconds I'll put the answer on the presentation here. You can pause it if you want to try on your own. All right, so we find out that BD is equal to 9. In our next example, it says, given the figure below with OS parallel to UR, find the following: SR, OS, and the ratio of the perimeters. So here's our first proportion. We say 3 is to 8 as 4 is to x plus 4, where x is the distance from S to R. So in this case, the 3 is here and the 8 is the overall distance from F to U. The 4 is the distance from here to here, and the x plus 4 is the distance from F to R. So if we solve this, we end up with x equal to 6.7, or SR equal to 6.7. Then for part B, we see that 8 is to 7 as 3 is to x. So the distance from here to here is 8. 8 is to 7 as 3 is to x, where x is the distance from O to S. Solve that and you get OS equal to 2.6. Let me go back there for a minute. For part C, it says the ratio of the perimeter of OFS to the perimeter of UFR, and the ratio here is the same whether you're looking at a side or the perimeter, so it's a 3 to 8 ratio on the perimeters. Okay, for our next example here, we're given a triangle where we know that the hypotenuse is 3.68 and that these sides are equivalent, so we can mark them both with an x. And then we can set up this equation which says 2x squared is equal to 3.68 squared. That's the Pythagorean theorem, and on the left side the 2x squared comes from x squared plus x squared. So divide by 2 and take the square root and you get x equal to 2.6. All right, finally we get this golden ratio. So the golden ratio goes way back in history, and this is a depiction of it with rectangles. And from this drawing here, it says that A is to B as A plus B is to A. And if you solve this, you end up with what's called the golden ratio, 1.618. And why don't you do a web search for that, and you can see that this ratio appears all over the place throughout history and in nature. And here's just one example of 1.618 applied to the Parthenon.